Okay, good morning, everybody, and welcome to the session. I'm Gabriel, Management Executive at First Digital, which is a first technology company. We are super excited to host today's event, and we'll give you a nice deep dive into one of the Microsoft Copilot family members, specifically GitHub Copilot. And we promise that this session will be valuable to non-technical people as well, because it clearly explains the benefits of consumer-based AI. Being from a software development background myself, I had first-hand experience of the panic caused by the so-called Y2K bug. Some of you might know or remember, it was due to a fundamental coding issue that led to fear that basically computers were going to stop working during the year change from 1999 to 2000. This was because we typically stored only the last two digits of the year, partly due to poor future planning, but also due to capacity constraints that actually date back to the 70s and 80s. So the software development world has really moved on since then and has become one of the cornerstones of modern electronics, the internet, and all of the modern digital innovation that we see. This has actually resulted that there are in the world at the moment a shortage of about 20 million software developers. So we clearly need all the help that we can get to write code. This is a quick introduction. In today's session, Rian Swart and Lawrence Himan will show you where some of this help is coming from by coding like captains using GitHub Copilot. But before we start, just a little bit of housekeeping. Today's session will be recorded and the recording will be made available on our YouTube channel. Details will be shared with you guys after the event. So please feel free to refer a colleague to it who might have missed today's session. Due to the size of the audience, and we are expecting a spectacular turnout, everybody will be muted on the webinar, and we ask that you post any questions that you might have to the Q&A window, which you'll see inside your Teams client. We'll try and ask questions during the session, but we'll also allow 5 to 10 minutes at the end of the session to cover any unanswered questions. The First Digital builds out many value-added services. Our business is based on 4 core pillars. Today, represented on this call with Lawrence and Rian is the First Digital Innovations team, and they typically do bespoke development, integration, cloud-based development, native cloud development, DevOps consultancy. Our quality assurance practice also exists in our innovation team, and more importantly, some of the interesting technology that you'll see today is coming from that team. Very briefly, the 3 other parts of First Digital is our automation team, where we look at automating business processes using workflow or RPA-based tools. Our First Digital workplace team, which looks after content management solutions, low-code development using Power Platform, Teams adoption, and some of the more modern add-ons to the Office suite, such as Microsoft Viva and Microsoft Syntex. And then First Digital data and analytics team, which really look at infrastructure services around data, SQL, deployment and management, Power BI, and data analytics using the likes of Microsoft ADF, Data Lake, and Synapse. So let's start at the beginning. There's a mix of apprehension and excitement in the technology world about artificial intelligence. And a lot of this apprehension is underpinned by the so-called unknown black box that it brings to the table. So let's start by clarifying that. And I'm going to apologize in advance for all the experts out there on this webinar. This is a massive simplification of a topic that is actually highly complicated. Neural networks, parameterized learning models, and deep learning models. But as I always say, being a good mechanic, as long as you understand how the pistons and valves work in a combustion engine, you don't really have to know the exact chemistry behind petrol combustion. So let's start at the beginning and try and just build up the story to what we'll be seeing today in Copilot. So on the slide in front of you see a very simple representation of data on the left-hand side, and obviously we have the ability to visualize that data. And I'm convinced that many of you have done that before, simply by creating a graph in Excel would be an example of visualizing data, whatever the source of the data might be. If we build on top of that, if we say, okay, right, maybe I've got multiple data sources that tell the same story or contribute to the same story. So now suddenly the ingestion of that data, getting that data into a common place in order to be visualized, and possibly aggregating that data or matching up data that might not have a direct relationship between each other. For instance, a customer could be represented in one data source using an ID number, and that same customer could be represented in another source using, for instance, a customer number. So during that analytical exercise, I'd obviously want to match these records up in order to come to a more accurate and a more trusted version of the data that I'm looking at. And we typically refer to that in the data world as data analytics. Taking that one step further, what I could do now is to say, okay, right, there might be some patterns in this data. So there could be historic data that I look at that could be used to make some sort of future prediction. And that is what we refer to as predictive analytics. So we basically build a rule set to simplify it in order to look at some historic data in order to predict what a future state of the data might look like. Taking another step on top of that, what's machine learning? So machine learning is the ability to predict a future outcome of data, but the prediction becomes a little bit more statistical. So for instance, I could be pulling some sales data that I'd like to visualize, and I also might be correlating some of that data to salespeople. Okay. And I can then construct a model that can make a correlation between the sales data and a salesperson. For instance, in order to predict, do I have a salesperson that is related to better sales? So there's a correlation in the data that might not be obvious in the data, or the correlation might actually not exist in black and white in the data, but the machine learning model that I construct can make a statistical prediction or statistical correlation between two data points in order to produce a new data point. That's typically what we refer to in the data world as machine learning. And ultimately, artificial intelligence basically takes this core concept to the next level. What's different from what we today see in the likes of ChatGPT, which we refer to as generative artificial intelligence, is that the feeding data set, the data set that's used to build this model, is enormous. For instance, all of the publicly available data on the internet, which means that the model, unlike a machine learning model, which has got quite a targeted input and output, in an example such as Copilot, which is underpinned by generative artificial intelligence, I can now use natural language to ask the question, because the data set is large enough and intelligent enough in order to interrogate a natural language question that I'm asking in order to generate a natural language response. And that's basically the foundation of what we see out there in the likes of ChatGPT, which is what we refer to as generative artificial intelligence. Okay, so before I continue my story, I'd like to run a quick poll on our audience, and you'll see that question pop up in your Teams client now. The question we'd like to ask you guys today: does your business today use any data visualization, which is the most simple version of the story that I started telling, or any artificial intelligence tools at the moment? So you'll see one of four options come up, and I'll allow everybody a minute or so to make your selection. Okay, great. So from the 20 responses we've received so far, overwhelming majority of you has indicated that you do visualize and do some sort of data analytics in your business today. About 15% do nothing. And then there are a small, tiny percentage of our attendees today that are familiar with machine learning tools and are benefiting from those tools in their business. So thank you very much for that. That's quite useful information for our speakers. So let's continue building on the story. So we understand now how generative artificial intelligence work. Obviously, the benefit of something like OpenAI, which is a model that's available in Microsoft's cloud, in order for you to build your own or benefit from generative AI in your own business context. The idea here is that you rely on the existing model that, as we know, has been built from large existing data sets, but you intersect that model or you feed that model with some of your own data, either structured or unstructured data. And the benefit here is rather than asking using natural language, the model with a question where it will typically answer in a publicly available context or a context that's obviously outside of your business, that you could now get an answer that's applicable to your specific business. And taking a step on top of that, in order to make the usability of this a lot better, we could surface this in, for instance, a tool set that you have deployed currently in your business, such as Teams, where the example I've got on the screen there, you ask inside Teams, first part, what is my leave balance? And it answers, it interrogates the question using the OpenAI generative AI model, and it brings you back an answer that's applicable to your business because it's got that underlying, it's got access to that underlying data set. Okay. And that's really the basis of Copilot, GitHub Copilot. The only difference with Copilot is that it is a specific instance of OpenAI called Codex, if you're interested in the theory behind that. And Codex has been built with a data set of code, publicly available code. Some of this is from GitHub, some of it is from other sources that the OpenAI Foundation and Microsoft had access to in order to build this OpenAI Codex deep learning model. And the result is that using a natural language statement, or as Rian and Lawrence will demonstrate, a comment inside your code, plus the context of your application, because obviously if you ask Copilot to generate code for you, you want it to create it in the context of the application that you're currently constructing, is that it then generates new code as an output. So there's a summary of Copilot. It's a generative AI tool available for a bunch of IDEs, Visual Studio Code, Visual Studio, to name a few. And it basically is an autocomplete on steroids, as Rian mentioned this morning. It's basically really clever autocomplete. That's got the ability to analyze your code, analyze its context, interrogate your natural language question or request that you're making, and then using the OpenAI Codex is to then generate the resulting code. It's obviously a paid for service, so a subscription is required, and Rian will clarify some of that costing for you. What's some of the benefits? At the moment, some statistics that's available is indicating that developers can write code 55% faster, which is a massive improvement. But one of the most interesting things that seems to be used by developers and Copilot is to write the mundane code, is to write the foundation code that developers typically don't enjoy writing. If you ask any developer, obviously they like the more technical challenges, they like the more complicated challenges than compared to the bulk of the code, which is what they need to write to make any application function, which is this foundational code. And that obviously is resulting in happier developers. Research indicates that developers using Copilot at the moment is 75% more happy than their peers. And they use the tool to write up to half of their code, 46% at the moment. There are some concerns, so let's quickly talk about that. At the moment, GitHub Copilot is a continuously cloud-connected service. So if there are any privacy or security concerns, those are valid concerns because it is a service that currently has to work in an always connected state. There's also fairly credible research that indicate that about 40% of code that's generated all suffer of the top 25 code weaknesses. So it doesn't seem like Copilot is actually writing any more secure code than what we would expect of a average developer. Okay. And quite interestingly, if you ask Copilot to write code, but you apply some conditions to the output that you want. For instance, Copilot, write me a statement that will iterate a list of values, but don't use a loop statement. So you're putting a condition to the output, is that the performance then greatly decreases. And it seems that it decreases to the point where human developers are actually still better at interrogating those conditions compared to Copilot. One of the big concerns that's currently unanswered is how this OpenAI Codex model was built. Okay, so we do understand that there's publicly available code that was used to build the model, Some of this code is licensed under the Open Software Foundation or the so-called fair use open source policy. And the question at the moment that remains unanswered, and there's actually a pending class action lawsuit around this at the moment, is does this constitute fair use? For instance, in the scenario where Copilot generates code verbatim, for instance, it doesn't actually make a modification from the code that was used to build the model in the output. It's essentially copying it, okay, which we do know has got some conditions in the open source world, and there are some copyright conditions within fair use if code is copied like for like from an open source repository into something that you might actually want to treat as closed source. So worthwhile watching this space. It'll be quite interesting to see what the conclusion is of this debate, which is ongoing at the moment. Great. So I guess that's enough of the theory. So without further ado, I want to introduce Rian Swart. He's an innovations lead in the First Digital Innovations business, and Laurens Human, who's a consultant in the same business unit. What they will be showing you today is a typical business application that's performing poorly. So it's got some performance issue in it. The first thing that they'll then demonstrate is how do they identify that poor performing application? How do they pinpoint the problem in the application and why it is performing poorly? And then they'll show you how they use Copilot to actually write some more effective code in order to fix this performance issue. So without further delay, Laurens, over to you.
Thanks, Gabriel. Hello, everybody. I'm Laurens. For those who haven't met me yet, my most redeeming quality is that I'm tall. So let's get down to it. All right. Can everybody see my screen okay?
100%, thanks.
All right. So this is a project that Rian and I have collaborated on. Let me explain the idea behind this app. So this came from a real life scenario that we wanted to solve. For everybody not at the Joburg office, we've recently had a new canteen shop that's making amazing toasties, but we've realized that they're still making use of paper sales. So we thought it would be appropriate to use this problem as the driver behind our point of sales application. So the application that we wrote is a Blazor WASM or Blazor WebAssembly. This is a single page application used for building client-side web apps using C#. So let me quickly check. What you will see here is the client-side project of it. This contains all of our front end, all of our UI elements. Let me just open this back up. This contains all of our pages, our services. Then we have a shared project. The shared project contains view models shared between our client and our server-side project. And then we have our server project or our backend project. So the architecture that we've used for this backend project is the repository pattern. The repository pattern with a code-first database approach as opposed to a database-first approach. Both have their own strengths and weaknesses, but for the purposes of this app, we chose code-first approach. As you will see here, the repository pattern contains a unit of work. Now, unit of work means that you've got a single transaction with multiple operations. This is important because if something fails halfway down the line, you want the whole transaction to fail. You do not want partially executed statements. That becomes very dangerous, especially when you've got an operation that wants to update certain data, insert certain data, and then if that fails, it's a big no-no. So what we have then also used, we've used an auto mapper to map between our domain models, i.e. our DB models or our internal domain models, between our view models, which is then presented on the front end or the client-side project. We've also made use of generic patterns for our basic CRUD services. CRUD is create, read, update, and delete services, which is typical for all type of data applications where data or databases are concerned. So let me move on to the actual application. Here we can see our Blazor WASM app. This is the store page. For the intents of the demo, we've basically merged our store buying part or add to cart functionality, and we've mixed it with the order history that basically contains a full order history of all the customers, their total prices, what they bought, etc. And then we've moved on to the product page. The product page is now where the client or the user can add their different types of products. As you can see here, we've added some Greek salad, some nice hamburgers, the famous toasty, all with their SKUs and prices. The client can come here and create their product, add their SKU as their price as they see fit, and then on the store page, they can then essentially sell to the customer based on which products they've selected. So our simulated performance is something that we've noticed a lot of devs or teams typically do. This is where, let's say, you bring your full table data. For instance, let's say we want something from order history. So the mistake that a lot of devs make is they pull the full database or the full table data into the application and then only start filtering, which means that most of the data that's pulled in is essentially redundant. It causes a big network traffic, and it also causes uses a lot of resources on the client side to be able to perform this type of filter. So the actual fix would be to filter on the database to only bring back the records you need. So without further ado, Rian, would you like to take us into the cockpit and show us how to fix the performance issue? And then just show how to use Copilot to help with coding and essentially solve our issue. But please show us a bit more about Copilot and what Scott Hanselman did, and let's keep the private life issues aside.
Of course, Lawrence. So let's start from how we identify that we have performance issues. So within Azure, we make use of App Insights. So the application will log all our data and telemetry within App Insights. And within App Insights, we will go in and set up an alert. And within this alerts, we've got a query that will go and filter for our requests. Let me just get to edit. So we'll look through those logs and we will go in the condition and find for all requests where the duration is more than 4 seconds. So this query will go and search those requests, get everything that's there. And then from our table result, we want to look at the count. And we then say, as soon as the count is bigger than 1, we need an alert on it. So this is how we identified our issue within our application with long-running requests within the system. So now, before we go into the code and things, let's go just discuss the GitHub Copilot, the licensing and the settings of it. So with GitHub Copilot, as an individual user, it will cost $10 a month. That's a software developer's Netflix subscription, something that's worth paying for an individual account. For enterprise companies' accounts, it will cost $19 a month, and it also allows for companies with an open-ended invoice enterprise subscription to have the GitHub subscription added into those licenses. So when you set up your GitHub Copilot for financial institutions, it's extremely important that your GitHub code is not coming from public code. When you set it up, initially it will allow all public code as part of your suggestions, and this can be blocked. So the financial institutions can still use it. It will only recommend reading what's in your context and not get anything from public code for you. Then if you don't want your code to help improve the GitHub Copilot, you just do not need to tick this checkbox to allow them for product improvements. By default, it is unchecked. If you want it, you will have to go and check it if you want to help them improve on Copilot. Okay, so once you've got the Copilot, you can install it into your preferred IDE. So within Visual Studio, you will go to the extensions and manage your extensions. We'll go and search for Copilot. And then just install it and restart your Visual Studio. This GitHub Copilot chat is a chat interface like ChatGPT interface that will be in your IDE, and it's still in private preview. They're making a lot of stride for this with the .NET 8 release. Okay, so with our query and our alert, we know that we've got a problem with the order history being loaded. So we load all our records within the system into memory, and only after that we start filtering it to display. Now, how GitHub Copilot in your IDE works is it works with comment paste. So you'll make use of comments to talk to Copilot, and in that comments, it will then suggest code for you depending on what your comment is. It's a natural language comment. So I would like to get page for the data from the repository and send the page data to the client. So when I'm entering, GitHub Copilot will then go and read, and it will start finding code that's in my code base that I can reuse. And this was for, so it's seeing it in a product repository that I've got. And I can just tap as it gives me the recommendation to insert the code. Now, sometimes like this code, you may not want to have it. It's not always accurate because I want to also include my page count, not just my data. Got the code copied here, so just send it in. So as a software developer, don't always just accept the code. Look at the code and make sure that you are happy with the code. Let's just say this all page data. Then this would be my result. Here we go. And then that would fix our problem. So that repository will get paginated data and filter it. I just want to check in so that our build can publish and get the code in. Filter out database call. So I just want to cover some more interesting code of generating some code with GitHub Copilot. So if I want to go and I want to create a console application just to seed my database. So let's go and add a console application. Database seeder. Can go and next. I'll create my project. So I'm going to add my reference to my service since all my infrastructure code lives within that service. So let's add that project reference. Okay. Now I want to go and create an instance for my context within my console app so that I can then start building up. So I will go and say, create a new instance of the contain context, making use of options folder to connect to server. Enter, and it's going to go and create me the options folder. Put that connection string in there, and I make my new context. Let's just go and fix up our references. So now I've got my instance of my context. Now I want to go and generate some data for my canteen or for my orders model. So I will go and type in a command and so generate data for canteen demo.server. It's under domain disorder model. And let's just go and say I want to go and make use of bogus. Making use of bogus package. And of course, it's now trying to do an order generator. I want to have it directly. So let's rephrase this a bit. Generate data, making use of bogus library for the context order stable. Okay, and there it goes, and it makes use of my faker for those orders. I can either type tab, and then I've got my order being faked into records. Let's go and install this package. It will generate my data for me. And then I can ask it, I need to insert this into my database. Generate 1,000 records. Insert the database context. And it went in there, so it didn't update this range, so I can go and update it myself. So in this manner, then Copilot will assist developers in getting their code done a whole lot faster than they would have done it normally themselves. Because the GitHub Copilot will then go and look in code examples within the GitHub environment, make use of that to also generate some of the code that I would be using. GitHub Copilot is not a silver bullet that will be able to fix any coding problem for you or find a bug. A developer should still be able to read code, understand the code, and then use GitHub Copilot just in a manner of helping you code the code faster. And that's what the GitHub Copilot is. Thank you guys for looking into that. If you guys got any questions, we would be able to answer them. Back to you, Gabriel.
Brilliant. Lawrence, Riaan, thank you so much for that. There's a couple of questions that's come up. The one that's crossing my mind as being a manager of developers in the past, Riaan, Lawrence, what are you guys going to be redundant in a few years' time? I think on a more serious. Sorry, Lawrence. On a more serious note. Sorry, Lawrence, go ahead.
No. I just wanted to mention we're not going to be redundant. Even the people using the Copilot code, if they are not code apt or not developers, you will have no idea what this thing is spewing out. So you will still need to have that driver intelligence and experience behind it. Yeah, that's it.
Yeah, very valid point. Very, very valid point. So just looking at the chat window here for some questions. One of the first questions I think was asked by Marshy, will the presentation be made available afterwards? Yes, both the recording and the deck will be shared with you guys in a couple of days' time, probably only early next week. We'll make sure that you get a copy of all of that. Lindsay made a statement that said, obviously pulling all the data into your middle layer or into your front end creates a security risk. I think Marcus responded to that by saying, DTOs obviously keeps that secure. Lawrence, Riaan, I don't know if you want to just comment on that briefly.
Okay, so with the GitHub, let me just share my screen again. Let's open the site. So when you have your GitHub and you subscribe, when you've an organization as their GitHub Enterprise and developers get their Copilot from there, the enterprise is responsible for the settings for GitHub Copilot. As a software developer with my own, I have to then set the settings myself. So if you don't want your code to go into the GitHub Copilot so that they know about it, you need to make sure that this is setting here for allow GitHub to use your code snippets to improve is not checked. GitHub Copilot with the suggestions will not take your code into the cloud to give you suggestions. It will use your current code environment that you're in that Visual Studio, and then make use of that code base to give you suggestions relative to what you're coding at that moment. So it will not go and send your data into the cloud. It still just lives within your IDE of choice. It will not go outside that IDE. The suggestions are built from your code. It's just a module that understands how to code, how coding languages should work. If you blindly follow GitHub Copilot, you will introduce a lot more bugs into your system than what you wanted to. But it is good to help you with that mundane tasks. So they will not take your code into the cloud. Your code is still secure, it's still your intellectual property, and it's got nothing to do with GitHub Copilot. It just assists you as a developer to speed up in your development processes. Did that answer your question?
Right. I think Lindsay's original question was around the actual use of data transfer objects, but I see there was a follow-up question that you quite elegantly answered there, Rian, with regards to protection of intellectual property and your code. And
yes.
Obviously that setting is quite critical in order to make sure that code is retained by the organization and stays there if that is indeed the requirement or the condition.
Yeah, the DPI object, I did answer that in the chat, and we're making use of AutoMapper to convert from DP to the DPI.
Okay, great. Okay, excellent. Another question came from Emil. Does Copilot assist with all code documentation? So good question. I don't know, Lawrence, Rian, if one of you want to cover that one.
Yes, I will. So no, Copilot is not there to assist with code documentation. What Copilot is you type within comments within your code of what you would like to have written. And GitHub Copilot will assist in writing that code for you, but it will not do documentation on your code. There's other tools available in the market that will look at your code and then document that code for you.
Okay, great. And I can appreciate why that question comes up, because we're talking about Copilot automating mundane work for developers, and we all know how much you guys love documentation. So who knows where Copilot might lead to in future evolutions. That's about all the questions that was asked. So I'm going to grant all of you about 20 minutes back in your diaries. Just before we conclude today's session, we will include some links that you will see in the screen in front of you now. There's a getting started landing area for GitHub Copilot with a link in there. We've also specifically put a link in to cover the costing of Copilot. That's always a question that comes up in terms of how much is this going to cost and what's my costing options. And so we'll include a link in our presentation specifically around that. And then just before I finally conclude, I just see one last question pops up. Let's have a quick look at that. This one is from Selendra. In the code, cybersecure, it's not adding cybersecurity holes that may be necessary to picked up by developers. Yeah, that is a good comment. If you recall one of the first slides in terms of the concerns, at the moment, at least, it seems that Copilot is not writing necessarily any more secure code than developers. So obviously, your multiple layers of security checkpoints still need to remain in place, regardless if the code was written by a human or developer. And Rian and Lawrence, I think you'll agree with that.
Yes, now, exactly. So within your pipelines and in your integration section of your pipelines, it is recommended to have a service like SonarQube that can scan your environment and make sure that it is secure. If you aren't willing to pay for SonarQube, the cloud services where you pay per lines of code, you can always set up your own local environment for SonarQube, making use of the open source project that's on GitHub. But you will have to compile it yourself, install it yourself, and maintain it yourself. But you need to always do that security. The GitHub Copilot takes your code, what you've currently done, and what other developers have done. And all developers can make those mistakes. So always have that step in place within your integration process to scan your code for security risks. It's something that you should have as part of your software development lifecycle.
Okay, great. Thanks, Rian. Lawrence, thank you very much to the two of you for today's session. To our audience, thank you very much for granting us the opportunity to talk to you about this topic. it's quite exciting. It's obviously a very popular webinar, so clearly a very popular topic. And if you want to get in touch with us to discuss any of this, either the implementation of Copilot, you want to talk to a licensing expert around the costing, please reach out to us. The final link there on the screen is a URL, a dedicated page for artificial intelligence on our website, firsttech.digital/AI. From there, you'll find some contact details, so please feel free to reach out to us. But from myself, Lawrence and Rian, thank you very much for joining today's session, and we hope you have a great day.
Yes, thank you for having us.
Thanks, everybody.
Cheers.